In this video, we're going to be writing a method that will remove any duplicate nodes from a linked list. So what exactly do I mean by that? Well, let's actually draw it out here. So I'm going to assume that I have this linked list that contains a bunch of nodes that store characters. And let's say that my linked list change looks like this, assuming that front points to here. So I've got basically data which is kept in this linked list. Now, what I eventually want to do here is I just want to remove any duplication or redundant nodes from this list. So what exactly do I mean by that? Well, I want to keep the D because the D is fine. In this case, I want to keep this first A because it's the first A I've seen and there's been no duplication, so that's good. And then T, there is no duplication of T, so I want to keep that. But I now see this next A, and I somehow do not want to have this A. I don't know why I drew an arrow there. I should have drawn a cross here. I do not want to have the A there. So the idea is, how do we actually approach this? Let me actually try to draw this all out here as far as things go. So actually, that was a little crazy there. So we didn't need to do that. We needed to keep it like this. So clearly, what we wanted to do is we want to be able to traverse through our list here, but we also want to somehow keep track of any counts of numbers that we've seen before. So one way we could actually do this is we could actually use a data structure called a priority queue. Priority queue. And in this case, our priority queue could have, say, fields like it could have, say, some generic type, which would be its data. And then it can also have another field down here, which would be of the type integer, referring to the frequency that we've seen of this data. So this would be a pretty good solution because what we could do is we could process the D here, and then what we do is we add the D and a frequency count of 1 to our priority queue. Then we process the A, do the same thing, process the T, do the same thing, and then once we process this A here, we could already know that we've seen it in our priority queue before with a frequency denotation of 1 here. So what we could do is we could somehow skip over this. So let's actually go in depth for how we skip over things. So one of the biggest problems is if we say create, I want to create this thing called current, which is going to be pointing to F, which points here. So the biggest problem here is I look at the D, that's fine, process it, current moves forward. Look at the A, it's fine, process it, move forward. Look at the T, process it, move forward. But then I look at this A here, and I somehow want to jump over this A. Now there's one big issue here. Our linked list class, actually more specifically our node class here, it only contains a reference to the next node in the list, and this is a big issue. If we kept track of the previous node, it wouldn't be so bad. So what we need to actually do is we need to keep track of current, but we also need to keep track of something else, which will just kind of refer to the previous value. So what exactly is previous going to do? Well, previous is going to point at the node before the current so that we can say if the current node that we're looking at is a duplicate, we can just say that our previous is going to skip over this node. And that's actually going to give us the effect that we want, because what will happen is we'll say previous is going to be equal to whatever current.next is, so it's going to be pointing somewhere over here, and then that changes the pointer of this node, and then when we move current to the next node, we actually do lose track of this node over here. So that's going to be the idea behind this. We can use a priority queue, but Gayle, the author of Cracking the Code interview, suggests using a hash table because it's very quick and efficient. So to basically help us along, instead of using a priority queue, we're going to be using this hash table here for checking as to whether or not we've seen any duplicates. So let's go to the linked list class here. And here we can see our remove duplicates. So what we actually need to do here is we need to create a hash table. And this hash table, we're just going to call it H. It's going to be equal to a new hash table. Let's actually take a look at the constructor for a hash table. So the hash table does take in a string and say an integer here. In this case, we're just going to have our hash table take in, let's see, what do we want to take in? Do we want to take in a node or a truth value? We'll just take in t, and then we'll take in a boolean. So that looks pretty good as far as things go. The reason why I'm putting in the boolean is because we want to see if we've actually seen an occurrence of the current node we're looking at. Once again, we actually do need to keep track of two individual nodes. So we're going to have my node t, which is going to be current, and then we're also going to be having my node of the type t, which is going to be the previous. So one thing we do know about the previous is when we initially start our current at the very front here, it would only make sense that our previous happens to be pointing to null because we haven't seen any sort of previous value yet. We've only looked at one node. So that's why I'm setting it to null. Current here is actually going to point to the front. So what we're going to do here is we're going to run a while loop, which is going to say while the current is not equivalent to null, so while we're still within the bounds of our list here, what do we want to do? Well, the first thing we should actually do is we should say, well, what happens if our hash table actually contains the current value we're looking at? We can do something like h.contains. Let me actually take a look. Okay, so contains some key, let's see, contains a value. Test to see if the key maps to some value. The problem is if we just use contains and we look at values, because remember, hash tables link keys to certain values. The problem is our value is a boolean, and that means there are only two different values that the boolean can be. So that's not very good. We need to use contains key because we need to check to see if we've actually contained the sort of information of the, if we have seen the information of the current node. So if we say if h.contains key of the current data, let's put a curly braces there. So we know that we've seen the data. What we want to do here is we just want to say our previous dot set next is going to be set to the current dot, I believe it's get next, because that's what, because we want to do that little jump over. Let me actually verify that in my node class. Yep, get next. So that looks pretty good. Okay, so what if we've seen something that is new and fresh? Well, what we really wanted to do is we just want to kind of put it inside of our table. So we use h.put, I believe. Let's see. Yeah, h.push, put, and we need to put in a key and a value. So in this case, our key happens to be the current data we're looking at. And then the value happens to be true because we have seen it now, so we can officially say that it's in there. What do we want to do at this point here? Well, we should probably update our previous to be equal to the current. And what we can also do is we can say current is equal to current.getNext. But the thing is, we'd also have to do that up here as well. So since both the if and the else would contain that, we're going to reduce redundancy, and we're just going to say current is equal to current.getNext. Now, it's true that I do have this function which says setNext, so we could say current.setNext is equal current.setNext and pass in this, but this looks a little bit nicer. So let's actually save all this, and let's try to verify to see if this actually works. So hopefully we didn't screw this up in any way, shape, or form. So it's good to compile our programs. So let's compile the driver class. Let's see, new hash table. Let me take a look up here. Linked lists. Okay, let's see. Where does the hash table come from? It comes from util. Okay, so this java.lang. Let me actually take a look at the message again. Hash table. Oh, okay. Well, we need to actually spell hash table correctly. So let's see. Hash table. Hash table. All right, let's compile this one more time. Hopefully we don't get any errors. Boolean. I believe it should be capital B here because it is a wrapper class. So my bad there. So what we're going to do now is we're going to run this and hopefully, yeah, there we go. We get the expected result. Once again, thank you to Gayle from Cracking the Coding interview for this solution. It's very helpful, and the main reason why I decided to make this video was because it's just kind of nice for me to review over simple um, questions like this as kind of a recap. So it's also very useful and very helpful. So I recommend that you guys write down the code first in pseudocode for for a solution to this problem, and then try to implement it. And then after implementing it, make a video on it. So we'll see you guys next time.